The next experimentation is the L system or Koch curve. Yeah. So this is the code, and first of all, we're going to talk about the components which we are using.
The L system or Lindermeyer system, what exactly is this? What happens when there is a sequence or pattern which is self-similar? We try to reduce the iteration, we try to minimize the usage of data. So what we exactly do is that we divide it into small piece components and try to so what we try to do is we try to reduce the runtime by using a recursive function. For Koch curve for this code, we are using variable say f. Starting is f, constants is plus and minus, and rule is when it's plus, it takes a right turn with angle 60 degree. This angle will be represented there in the code. Similarly, for right minus sign, it takes a left turn with angle 60 degree. The output is something like that. Since it's a single line, what we do is that we take, when we move for iteration 0, we are taking a left turn 60 degree, then again a turn of 60 degrees. This is for another iteration, say iteration 1.
Coming to the code part of it, here's the main function, and we have taken the initial line at x1, x2, x1, y1 and x2, y2, and then we have passed on the values to the recursive function. We are taking the number of iterations from the user. So here's the recursive function, which is then here we are calculating the values of the x and y with the angle 60 degrees. So as you said, 60 degree means take a left, and plus means take a left, minus means take a right. So yeah, so therefore we are using cos angle and the sine. So for cos 60 and sine 60, which is just the opposite. Cos 60, if cos 60 is for 60, then cos 60 is 1 by root 2, and cos 60 is 1 by 2 and sine 60 is root 3 by 2, which is here and there. So here we will calculate the value of x and y, and here's the plotting is done. So if the number of iteration is about more than 0, so here we'll plot the curve, which is like recursively calling the function again and again. And if the number of iteration is when this it, which is the iteration number, is 0, we'll plot the lines. So these lines are plotted with the x and y we are calculating with every iteration. So we'll run the code. Yeah. So first we'll put number iteration as 0. So here's the basic one. Then we'll put number of iteration as 1. We also put the delay function so that we can see the number of iteration going on, which can be seen when we increase the number of iteration. So number of iteration is 1. Then probably we'll put 4 here. Yeah. Yep. So I can see 4 iteration. 1, 2, 3, 4. So maybe we'll put 7 in the next one, which will run slow. Yeah. F10. Yeah, so that was a demonstration of the L system or the Koch curve. So thank you. Tada.